We are being live streamed and the stage is virtually yours. Over to you, Munmun.
Yeah, hello everyone. Good morning, good evening. Welcome to another hour of data, another session of DataHour. I hope you guys are also excited as I am. Let me share my screen. Am I audible perfectly?
Yes, ma'am. Yeah.
Yeah, just let me know if my screen is visible. Is my screen visible?
Yes, ma'am.
Okay, so let's start. So today our topic is exploratory data analysis with Python, and we have taken the dataset, a very simple dataset of Netflix. So let's dive in. So I will be giving a brief overview of EDA, what are the techniques of doing EDA, and then I will straightforwardly go into the code, like how we can do, take the dataset, load the dataset, and we can do the the necessary steps for EDA. So already the moderator spoken about me, and I am also repeating myself for long in several sessions. So nothing like no more time I will waste on this. Just like I am having 16 years of experience and I like to learn new technologies. And also I am like very passionate about coding. So at any time I get, I doodle code actually. So that is one of my passion. From my hobbies, like I like traveling, trekking and off-road biking. So I will just go straight into the topic. If anything else you want to know about me, you can always, ping me in LinkedIn. I am there. So I think my link is shared. Exploratory data analysis is an approach of analyzing and understanding data that is focused on finding patterns and relationship in the data. So rather than testing the hypothesis or making predictions, we are mostly, understanding and analyzing the data, the different variables, how these variables are related to each other, what is a pattern in the data, and we are trying to visualize like some of the patterns and finding the relationship. So that is more about exploratory data analysis. Okay, apart from that, there may be some anomalies in the data or abnormalities because we are always fetching the raw data. That data is not clean enough. So before we load this data to any machine learning model or we train this data, basically, we need to clean this data. So there can be many abnormalities or, the values can be missing for certain columns. There can be outliers. Then we can, have to, get some derived metrics from the data. So all these things is a part of, are the part of exploratory data analysis. So basically, it formulates actually 35% to 45% of any data analysis project. Just let me go to this next slide. So most of the time, what happens in real-time scenarios is that when we fetch the data and raw data and we do EDA, most of the time actually the data analysis is done, like for most of the projects. Like we don't even need to train a model or to do any, build a machine learning model. So EDA, that's why EDA is a very important step because it takes some time to, analyze the complete data. And sometimes the data set is very complex, which comes is very complex. So like today we will demonstrate a very simple data set, but in real-time scenarios, the data set which comes is very complex. You need to understand each and every variables, like what are the columns, what is it all about, and how it can, impact your target variable. So these things are very important. Okay, so I have written like what are the things I am doing here in EDA. So that is all, and like this is a you can take a like a schematic diagram. Like we are taking a raw data and we are doing all this feature engineering, and that data we are putting into machine learning model. This is very simple to explain. So now the various steps. Okay, so now the first step is data sourcing. So most of the times, in the industry or from the client, you will get the data. So there are lots of data available with the client itself, so you will get the data. And this part is actually done by the data engineers, like the proper pipelining, like what will be the frequency of like bringing in the data, like how from which sources they are bringing in the data. So all these things are the part of data engineering. If the client data is not present, then sometimes we need to like do the analysis on the public data also, or the data which is available in public domain. And like for that, there are several techniques. You can fetch the data either by web scraping or by like calling some APIs. If any public API is consumable API is available, you can call the API and fetch the data. So in my previous session, I have shown some of the techniques of web scraping, how you can scrap webs, how you can automate web from like using Selenium library or from the VBA itself, or just calling the API. You can consume some APIs, REST API, SOAP API, and you can fetch the data. Or otherwise, there are some libraries available also, like Beautiful Soup, Scrappy. These libraries in Python actually facilitates in web scraping. So I am not going into that detail. Then comes the data cleaning. So this is basically the step of EDA. So data cleaning, in the data, as a part of data cleaning, we do the missing value analysis, like whether there is any null value, then whether there is any outliers, this we need to treat. So this is a part of the data cleaning. Okay, then we analyze like what are the categorical features and what are the numerical features. So a data set can consist of both the features, categorical and numerical. So we need to understand that the data point or the variable we are analyzing, whether it's a categorical data or a numerical data, and based on that, our analysis steps will be, or the pattern or the visualization we will be using will be depending on that. So basically for categorical feature, we do three kinds of analysis. This is univariate, bivariate, and multivariate. So univariate is when you are like, like analyzing only one variable or only one data point, then it is univariate. Bivariate means when you are trying to getting some relation between two variables. So that comes under bivariate, and multivariate means more than two. So when you are doing like the analysis based on the different variables. Suppose if I give you example, like you are trying to figure out the price of the house, and you have used some other variables like the floor size, the floor area, or the location. So these kind of parameters you are using, and that it like it can be more, the number of bedrooms, number of washrooms. So like that, you can, if you take like all these variables together to just like to understand that how it is related to the price of the house, then that is kind of a multivariate analysis. For numerical feature, you can do correlation. So the correlation is the best thing we can do. Like we can find out the correlation between the two different variables or the multiple variables. So that is one thing. And we can see some trends like line charts and all, and the distribution, the disk chart and all, to like to understand the pattern of numerical feature. There can be some derived metrics also. So what is derived metrics? Derived metrics means when you derive some other metrics from your existing data for the purpose of for the purpose of analyzing. So I will come to this, that what exactly it means. Let me go to the next slide. Okay, so like data cleaning. So there is actually, like steps of data cleaning or handling the missing values. So it is not like that. It is like, like you just ignore the missing values. There are some, like techniques to do it. So first one is, I have tried to, like put it point wise. So first one is deletion. So when we will do deletion, so again, data science is a science without definition. There is no definition like to do any hard and fast rule is there that you have to do like this. It depending on your analyzing, like analyzing or your domain experience, that you can understand that what you exactly need to do on the data. And like it can vary on the people. Like what I am doing may not be like the person sitting with me is doing the same. So it may vary, because it will like depend on my decision making things. So deletion. So when we will delete the missing values, when the large population of data is missing. So suppose if a large population of data is missing in the columns or rows, then we have to think that whether like that column itself we will be needing or not. Because if say more than 70% or 80% of the data is missing in a particular column, so like that is a thing that we need to check, that whether this column is at all required to do the analysis of the data set. So then we can like go and directly drop those columns. Okay, for dropping the rows, we can see that if the like the population is very less, that we are dropping. Actually, the number of rows is very less, the percentage is very less, which is containing the missing values, that we are dropping. So again, like the deletion will like take some strategic decision on that. Then imputation. So how you can impute data? For imputation, you can use some statistical measures like mean, median, or mode, but it is not that it is the thumb rule to use that, because like it is not that like we can always impute with mean or median or mode. So I will tell you how, because for the numerical data generally we will like try to impute with mean or median, but depending on the symmetricity of the data. So if the data is not symmetric, basically we will try to like impute with median. If the data is perfectly symmetric, which is not like the ideal condition, it never happens, like the raw data which we get, so we will sometimes impute with mean. Okay, and mode is like when the data is categorical. So but it is not the same, not the thing that we can always impute with mode, because I will tell you. So if I have a data set and I have a profession, like the profession given as doctor, then technicians, engineers, and say like the number of occurrence of doctor is more. That doesn't mean that whatever the values which are missing in that column, I can impute with that only doctor. And it depends, like it actually depends. If the percentage of the missing value is very low, then I can impute it with mode. But if the percentage is like very large, then we need to see like what can be the way we can impute that value. Okay, so this is one thing. Secondly, there can be some machine learning algorithms where we can predict the missing values. So these are the ways of imputation. Now, interpolation. So interpolation is that when you have two variables which are very much near to each other, and from one variable you can actually like interpolate the value in the other variable. So let me give an example. Say for a like if you are doing a credit analysis. Okay, so if you have if you are applying for the loan, so and you are buying a product, so the good of the basically the price of the good. Okay, so generally what happens is, if these two columns or two variables are given, generally what happens that what is the price of the good is generally my loan amount which I apply. Correct? Like the price of the good is always very much correlated to the, or highly positively correlated to the loan amount. So that time, if my price of the good is not missing, or my loan amount, I can take that value, interpolate that value from the loan amount. So for the respective loan amount which I have received. So that can like that we can conclude that the price will be near about to the value of or the amount of the loan I have received. The price of the good will be near to the amount of the loan I have received. So that is a process of interpolation. Now, what is extrapolation? Extrapolation involves estimation of the missing values by extending a trend or pattern that is observed in the existing data. But this can be risky, because always the trend and pattern may not be like the case like when you input the things. So it may happen that you are just like understanding a pattern, that how the data is coming, and you are extrapolating, and you are trying to impute the missing values with the same pattern. Suppose, let me give you an example. Suppose one M and then two females occurred, like MFF occurred. Like then, if you get some missing values, you try to like extrapolate the data with the same pattern, like MFF. But it cannot be like the same case every time. So this is again like these things are like depends on your experience and like the decision or the strategy you are seeing in the data. So those things are never like will be matching with each other. Like when the 10 people are working, it will be never matching with the 10 people, because the views will be different, because there is no hard and fast rule in this. But we will try to do it like seeing that it like the impact is very less on the overall data set. So let's move to the next slide. Okay, so data cleaning, and for data in the data cleaning step, we have another thing called treating the outliers. So there are also some patterns how we can treat the outliers. Basically, we plot a box plot to see whether there is any outliers in the data. So basically, we will also analyze that if the outlier has come through any data mistake. So the first step is that identify and correct the error. So we need to see that if in the data entry any error has occurred for which the outlier has come. So that can be corrected. So in that way, outlier can be treated. Otherwise, you can ignore the outlier because in EDA, like EDA is just on the data analysis part. So like if you're ignoring the outlier also, it is fine. That won't create any problem. Yes, but for the data cleaning, like if you're putting the data for the, like next into the machine learning model, then we need to treat the outliers. Then we can trim the outliers. We can cap the outliers with some threshold values. Maybe it is the upper value or the lower value. So say like if the salary is, if the salary is beyond, like some outliers are coming, that salary per month is beyond 2 lakhs INR. Then I can cap it with 2 lakhs. So whatever is the upper limits, I can just put a threshold limit that whatever is above 2 lakhs, I will just cap everything with 2 lakhs. So that is kind of a trimming the outlier. Then transforming the data. Okay, so transforming the data means when the data is occurring in a different scale. Suppose the data has occurred in the centimeter and inches. Okay, and you need to, like scale in the one scale only. Like you need to convert all the centimeter data in the inches, like dollars and cents. So then you can, like for that also, some outliers can happen because centimeter scale is like bigger. So we can see some outliers, but maybe it is like if you change the scale, we can, if we transform the data scale, then the outlier problem will be solved. Okay. Then impute the outliers. Also, outliers is a result of missing values. It may be appropriately imputed by the missing value. So once we will do the imputation of the missing values, maybe the outlier problem can be, some of the outliers can be, like treated. So these are some of the, like ways we can treat the outliers. Okay, so I will be little bit giving this definition because this is important before we go to EDA. And to understand, so what are the kinds of data basically we will be seeing in our data set. So one is qualitative and one is quantitative. I think most of the people knows about it, but still I am just giving an overview. So qualitative data can be nominal and categorical and ordinal. So it can be in order also. And quantitative data is discrete and continuous. So what are these? Basically, I will explain in detail. And discrete can be interval ratio, and again continuous can be interval and ratio. Okay. So nominal data is qualitative and categorical. What can be the example? The example can be color, country, labels, gender. So all these are categorical data. So order does not matter here. It is not in order, right? So it is just like, if you say like male, female, so it is a categorical data, right? There is no order in it. What is ordinal data? Ordinal data means when you are putting like, when there is a position in the pattern, like if you are saying that very low, low, fair, good, very good. So it is actually, like telling the position, defining the position that very good is better than good. Again, good is little bit better than in a better position than fair. Fair is in a better position than not good. So like that we can, like do some positioning of the data. When we can do the positioning of the data, it is ordinal data. And even the rank, like 1, 2, 3, 4, 5, right? So like that, the ordinal data also exists. Okay. It may be in the numerical form, it may be in the text format, but that doesn't mean that we can take the definition of the data like mean, median, all these statistical measures, because it is just, like reflecting the position of the data. Interval data means when there is no zero starting point. That means the data can be negative. The order also matters. So if you say about the temperature, like minus 30 degrees centigrade to minus 20 degrees centigrade, that is an interval scale data. Okay, and also the differences also can be measured, right? Ratio scale data, when there is a starting point, like when it's a zero starting point, that means the data can be starting from zero. So say, suppose the number of people present in the meeting room, it can be zero, right? But it cannot be negative. So that is a ratio scale data. So let's see some examples over here. So these are some examples and where this falls actually. So if you see age is ratio continuous, so age can be, like told in the continuous fractions also, like 10 years, 6 months, like that we can say define the age. Then weight is again ratio continuous. Weight also you can say 49.5, 50.6. likewise, we can, define the weight. Disease is nominal, like disease yes or no. If you are putting, when you are putting that, it is a categorical data. Again, sex is nominal, country is nominal, hair color is nominal, income ratio is again continuous. Okay, number of people in the meeting is ratio discrete because it cannot be decimal. First of all, that's why discrete, and it can start with the 0. So it cannot be like no person is there in the meeting room. Then number of birth in the day, again it can be ratio discrete. Like discrete means it is not containing the decimal value, but again it can start with the 0. Then coffee size, like it is small, medium or large, it is ordinal data. Okay, there can be some other data group also, like identifiers, where we give some like product ID, order ID, customer ID. So these are some identifier data. Though these data sometimes comes in alphanumeric, sometimes in numeric, but that doesn't mean that we can define the data with the statistical measures. Again, ordinal and nominal data can be converted to numerical. So let me give you an example where ordinal and nominal data can be converted to numerical. So I given the example of like very bad, fair, good, and very good. So if I just put it in the numerical value, like very bad in the 1 to 5, if I give the rating as very bad as 1 and then bad as 2, and then fair as 3, and good as 4, and very good as 5. So there I can represent the ordinal or the nominal data as a numerical format. Again, numerical data can be converted to ordinal or nominal data. How we can do we can do grouping. Suppose say like the age is given, even for suppose for the Netflix data, right? If the age is given, like, so this is a program from 3 to 10 years. So I can group that from 3 to 10 years, it is the children program. So I can group it as children. Then 10 to 15, I can group it as teen. So I can put it as a nominal value, some categorical values. So likewise, it can be converted to the ordinal or nominal data. So these things I explained, this is actually, you can say like what is called as a derived matrix. So when I am deriving some matrix from or whatever existing data is there, it is called derived matrix. Suppose what it can be, let's see. Okay, so suppose the beginning of the data, like I said, like 5 to 10 years, it is a children group, right? Then likewise, we can, derive a matrix and we can put like another column we can put and we can say this is a children group. Then 10 to 15 years, I can put as teens, right? So I can derive some metrics from my data of age. Then encoding, we can encode. How we can encode? We can encode like depending on anything, like suppose say, male, female. So if male is there, then I will put as 1. If female is there, I will put as 0. So I will put another column there, and where I will be just encoding the data, whatever the existing data. So that is the way of encoding. Calculated. So suppose like if my sales is given and if my production cost is given, then I have to get the profit, but profit column itself is not given. So I can derive that by calculating my sales or the revenue minus my production cost. So that will give me a profit. So likewise, I can calculate some column. So that is like the derived matrix. Okay, and from the data understanding, like understanding the data, if you want to, get some more derived matrix depending on your experience and understanding the data pattern, then also you can get. So these are some of the ways of getting the derived matrix. Okay, so I will take the questions later in the last. Let me go into the data set or the Python notebook. Okay, so this is basically I have prepared the notebook and kept for the interest of the time. So here we will be analyzing the Netflix data. The dataset is very simple, which is available in Kaggle. I have taken it. So this is the Netflix data. So I will be just imported some of the libraries, the pandas, numpy, matplotlib, seaborn, which is required for the visualization and for for the calculations and for the analysis. So I will just run these cells one by one. So this is my data set, that is netflix.csv. I am directly loading it into my data frame. Now I will inspect the data one by one. So what I can see the first 5 rows of the data, like how it is coming. I can see the last 5 rows of the data, how it is coming. So see, this is the data which is loaded. So we have all these columns like show ID, type, title, director, cast, country, date added, release year, rating, duration, listed in description. So these are some of the columns are there. Now let's see the last 5 rows. So again, these are the columns which are coming. So same columns only, but the rows are different. Okay, so this is the ID is 1806, you can see. Okay, let's see how many, like the shape of the data, like how many rows and columns are there. So this is the rows, number of rows 1807, and the number of columns is 12. Fine. If you want to see like what are the different columns are there, you can just put df.columns. So it will give you all the different columns, the column data which is there, like the column headers, the header names, which it will give the header names. So for the small data set like this, we can see the column name from here itself. But for a very big data set which doesn't fit into the frame, then we can use this method to see like what are the different columns are there. So if I put data df.info, it will give me the info of the data. So if you see here, now this is interesting. If you see here, it will show you that if you see the shape is shown as 8807, that is number of rows, right? But if you see that for some of the columns, number of not null object is less than 8807. That means these columns have some null data. So that is signifying that these columns have some null data, like this one, this one, this one. So from the info itself, we will understand which are the columns having null data. And also you can understand one more thing, and this is data type. Like what is the data type? Like if you see the release here is integer only, rest all the columns are in object. So likewise, you can see the variables like the data type, whether any not null count is there. Okay, so let's go deep. Let's go to the next code. Okay, so if I do describe means any numerical column which is present in the data, it will give me a statistical measure. So if you see only release here is a numerical column here, no other numerical column is here. So for the release here, it is giving me a statistics like what is the count, mean, standard deviation, though it doesn't make any sense for a year. Year data. So, but it is like it gives for any numerical column, if it is present, it gives a statistical measure like 25 percentile, 50 percentile, 75 percentile, max, mean, all these things. Okay. Now let's see like what are the missing values here, because we already observed that there are some missing values. So let me just run this code, and the code is very simple because I won't put stress on the code, because if you search this code, like what is how you can find is null for the data frame, you will find thousands of tutorials or the topic in Google. Even the Pandas official documentation also, you can understand the coding. So I am not putting much stress on the coding. This code is very simple. So I am just checking that what are the null values here in the entire data set. So if you see, these are some of the columns which are containing the null values. So director is containing around 2,634 null values. Then country, then caste. So these three are the highest. Then these are very nominal, like date added, it's 10, rating is 4, duration is 3. So these are very nominal. Fine. So let me just see the percentage also, like what is the percentage? Now percentage of the null value on the entire data set. This is important because we need to check the percentage, because if we see that it is more than 50% or 60%, then probably we may drop the column, because if the column is containing like most of the values as null values, then we will probably may drop the column. So checking the percentage is important for that. So if you see here, director is 29.91%, country is 9.44%. So these values we can treat actually. Some null values we can treat because these are missing values. Okay. Now let me just do some analysis, like univariate analysis. You can say like we are doing the analysis on one variable. So let me just see like what is the director value count. So these are the director value count. So you can see like the top directors also you can find out like this. So if you just put head 10, the top 10 directors, so it will give you the list of top 10 directors. Okay, from the data. So likewise, we can see the top 10 directors. Okay, then let me just understand that movies versus TV shows. So again, like I am checking one variable with another variable, right? So this can be a bivariate analysis. So we are using two variables. So I am just checking that what is the percentage count over here. So I have drawn a donut plot over here, or a pie plot with a hole in the between. So it's a donut plot basically. So if I see that there are 69.6% movie and 30.4% TV shows, okay? So this is giving a clear indication that there are more movies than the TV shows, okay? And the percentage is given. So likewise, I am doing some analysis over here. Then I can see the type. So what are the types? Like the types already I have plotted in the pie plot, but still I want to see the values. So what is the exact value? Like for movie it is 6131 and for TV shows it is 2636. So this is also indicated here in the percentage. Okay. So then say I want to see the rating also. So what are the different kinds of rating present? So this is the rating which is present, and if you want to see it in the bar plot, so this is how it is coming. So it is TVMA has the highest rate, like the highest number of TVMA shows are there. Okay, then followed by TV14, TVPG and R. Now, what are these TVMA, TV14? So you can find in Google, like what is this rating all about? I have also searched and I have written over here. So TVMA means basically the program which is intended for adults. Like MA stands for mature audiences. Children aged 17 and younger should not view this program, and that has the highest count. So TVMA has the highest count. So this is one kind of an analysis we are doing here, like one pattern we found here. Then followed by TV14. So TV14 is again like the program which is not meant for which is meant for the children over 14 years. Below 14 years, they should not watch. So that is TV14, and the largest and the third largest is R rating. R rating means it is restricted. So young person below under 17 should not watch. So these three other, like like TVMA, TV14, TVPG, R, these are kind of like the top 5 like categories which we are seeing here, like which are having the highest counts. Okay. Then going forward, if we see the country counts, like country-wise, how the count is coming, and if we were to find that the top 10 countries, which is giving the content in the Netflix. Okay, so you can see the United States and then 10 followed by India, then United Kingdom, Japan, and other countries are there, South Korea, Canada. So this is also you are seeing that that how the data is like coming over here for the countries. Okay, so this is the same thing only. I have just used it in the previous line only. Okay, now if you want to see the year-wise count. Okay, so I am just doing all kinds of analysis on this data, like how the year-wise counts are coming, how the country-wise counts are coming. So this is the year-wise count, and if you see this, you can see that 2018 has seen the 2018 has seen the highest content in Netflix. Then followed by 2017, 19, 20, like this. So the top 5 is 2018, 17, 19, 20, 16. So this has seen the highest count, like highest releases in the Netflix. Okay, so this is also another thing. So these conclusions you can write in your dataset, like highest release in 2018, followed by 17 and 19. Then top 10 directors also you can see. So who are the top 10 directors? I think that I have seen before also. Okay, then what are the listed in data there? So you can see like this is basically the genre of the data, like dramas, international movies, documentaries, stand-up comedies. Then all kinds of these things are like children, family movies. So I think the highest one is drama and international movies, then followed by documentaries and stand-up comedies. Okay, if you want to see the lowest data, you can find out from here, like from just putting the tail. So this will give you the lowest data, like these cult movies and all, kids, Spanish language TV shows. So these are like the lowest content over here. Okay. Now let me just plot this also. Okay, so the same thing I have plotted and it is showing the same result. So whatever I'm seeing in the data, it is just giving a visualization. Like from the visualization itself, I can understand that this is containing the highest count. Dramas, international movies and all. Okay, now the important part, like now I have little bit analyzed all the columns over here, like the top directors, top 10 directors, and top 10 countries who are releasing the content. the year which has seen the highest number of, like the films or the TV shows. Then what I can do is I can go directly like how I can, like treat the missing values, because already I have seen some missing values in the data. Okay, so I am just, like writing this code and I am saying that what are the missing values there. Let me just put it for the decimal 4 places also, like if anything is getting missing out. No, I think all till duration only we have this 6 count. So let it be till 2 only. Okay, so now if you see this missing values, if you see this one like duration, rating, and date added, these values are very low. The percentage is very low. So like one is 0.11%, another one is 0.05% basically, and 3%, right? So it is like not even 3%, 0.03%, 0.05%. So I'm showing in percentage only. So these values are basically overall data set. If you see like 8807 rows, these values are very low. So I can go and directly drop these values. Like if they are containing the missing values, I can drop this data. Like the missing values, I can drop these rows because the proportion is very low itself in the entire data set. Okay, so let me just go and drop that. So, okay, so I have just put some figures also, like what are the numbers coming here. So if you see here, like date added is 10, then rating is only 4 rows, and duration is 3 rows. So this 4 plus 3, 7, 7 plus 10, 17 rows I can drop basically. Because it doesn't matter for an entire data set, like which is containing around 8,000 data, right? So I will be dropping for rating and duration first. So I was not actually, when I was writing this, I didn't say for iterative, so I added dataset later. So for dropping also, it is very, like this code, I am not emphasizing on the code because this code you will find in the funders documentation again. Axis 0 means you are dropping row wise, axis 1 means when you are dropping column wise. And in place row means when you are directly saving that in the data frame. So you don't have to, like assign to a new data frame. You are directly saving it, dropping it, and saving it in the data frame. So true, false means that. So I have dropped it. Now let me see the shape. So now you can see that 7 data are deleted, 3 and 4. So now it is 8800 and 12 columns are already there. Okay. So now let me check for this one also. Like I will drop for date added also because this is also very less. And I will see again. So now, if you see here, date added, and then which one was there, duration, I think, and rating, these are dropped. So now the is null values are showing as 0 because there is no is null values here because I have already dropped it. So now the main majority is caste, country, and director. Okay. So let me see that how we can do this also. Now for the country, if we have seen like the highest number which was occurring was US and then followed by India, right? But like because US is occurring for the highest number of times, it is not suggested like like 9% data you are replacing with US only because it may not be the case, correct? So what we can do here, we can take an unknown variable here. So wherever I'm seeing the non values, basically the missing values, I can replace that with unknown. Okay, so I am treating my countries like that. Okay, again I am checking my data. So now my countries is solved. So countries has become now the 0. Like there is no null data there. Now the next is caste and director. Again, it is same thing. The director and the caste, these are also nominal or categorical data. But it is not, suggested that because it is occurring more number of times or some data is occurring more number of times, we can replace the data with mode. Instead, we can put as no director or no caste. So that way I have also replaced for director and the caste. Okay, so this is again like I'm seeing like what are the countries now available. So unknown is now 829. So I have replaced the data with the unknown. Okay, so now let me check about caste also. So if you see, this is a caste data available. So if I see the first 10 data, top 10 data. So this is the way the values are coming. So if you see that David Attenborough is 19, the highest, but it is not suitable, like, or it is not suggested that I can replace all the values with David Attenborough, right? So what I can do is I can put wherever the NaN is coming, I can replace with no cast. Okay, and the same with director. I'm replacing the director also with no director. Okay, then I will again check this whether my all the null values are treated. Yes, it is treated. I will check with decimal 4 also. Yes, I think all the values are treated. There is no null values in the dataset now. Okay, now on the next. Next is I can, like little bit, like see like what are the top 10 movie actors, okay, whose name is occurring more number of times in the title. So what is a title? So if you see the title data here, let me just insert another row ever. So if you see the title data is coming like this, let me just put all the data. Okay, so like this, the title data is coming. So now I am saying that now the actors' movies, which are like occurring more number of times in the titles, that I am trying to try to visualize over here. Okay. So if you see the more number of times the actors are, occurring in the cast, whose movies are occurring in the titles more number of times. So that is a way we are getting, like this visualization we are getting, where we are saying that Anupam Kher and then followed by Shah Rukh Khan and then Julie Tejwani, Nasruddin Shah and Takahiro Sakurai. So these are the first 5 or 6, like top actors. Okay. So then if I see, now I have done something. So I wanted to see, like I wanted to divide my data set into, this is again, there is no hard and fast rule in it. It is like I want it, so I have done it. Maybe somebody else wouldn't have done it, right? So there is no rule about it. But as I just wanted to analyze on this data set. So what I have done is I have like distinguish these two data, like the data set I have divided into 2 parts. In which way? Like I have taken movies in one data set and TV shows in another data set. So I have just put a log function and I have seen that if the type is movie, then take it in the movie DF. If the type is TV show, then take it in the show DF. Okay, so this is my data which is containing only the movies. Okay, only movies. Okay, and this is the data set which is containing only the TV shows. Okay, now if you see, there is one more column here, that is duration, and we haven't done any analysis so far on the duration. We have done on rating, we have done on release year, we have done on countries, cast, director, everything, but we haven't seen anything on the duration, like how it is, like how the duration is occurring over in this data set. Now, if you see, for why I have done this segregation, because for movies, the duration was coming in seconds, like 90 minutes, in minutes, 90 minutes, 91 minutes, like that. But for the TV shows, it was coming as 2 seasons, 1 season, likewise, the data was coming. Okay, so if I want to, like to do some analysis on the data based on duration, it will be very difficult to, like to get it in the one scale or one unit, because both these units are different. So for that purpose only, I have segregated this data set into 2 different data frames. Again, one is movies and one is shows. Okay, so now I will just replace. So if you see here, this duration basically for this movies data set is 91 minutes, 90 minutes, like that it is occurring. Now, what I can do, I can replace this minute term, because I don't want this term. I want to get a purely numerical value over here, like 90, 91, like that. So I will just replace this space minute term. So that is what I have done here. So I have just replaced this space and minute. And wherever the minute is occurring, I have just replaced it with space minute, and we have put blank over there. So now my data set is coming as like, it is clean. Now it is only containing the numerical data, 90, 91, like that it is contained. Now let me check the info also of this data set, movies data set. Now, if you see here, still it is not the numerical data, because it is showing as in the object format, right? The duration, though I have changed, I have removed the text from it, but it is showing in the object format. Only the release here is in the integer, rest all are object. Okay, so now what I will do, I will just change this integer object to the integer. So this is a code for it. So I am just changing the type of to the integer 64. Okay. So let me just change it. Okay. Now I have put a describe, and like describe is only happening on the numerical data. So now I know my data has been changed to numerical value because it is coming in the showing in the describe now. Not previously only release year was coming, but now duration is also coming, and where I can see the minimum, maximum, first quartile, median, third quartile, all the data I can see here. Now, an interesting analysis point, if you see over here, now this is a way you can analyze basically. If you see here, the minimum is 3 minutes. So that, like that curiosity will come, which movie will be like for 3 minutes only, like the shortest movie kind of. And which movie is there for 312 minutes, that much long movie, right? So you can just analyze that, like which is your shortest movie and which is your longest movie. You can put some query in the pandas data frame and you can find out that. So I have found out here that which is my shortest movie here. Okay. Now this is a movie Silent. So this is a silent movie. This is a director. And their cast was not there because I have replaced it with no cast. The missing value was there basically. The country was United States. It was released in 2014. And it is basically a children movie and the duration is only 3 minutes. So this is another kind of, like some kind of analysis you are getting that from the data set that the shortest movies is this one, the shortest movie which is occurring. Okay, what is only of 3 minutes. Then if you see for the longest one, so if you go here and you can just run this code. So basically I have just equated with np.max. But since you know the data over here, you can put like anything which is above than 100. That also you can put that greater than equal to 100 minutes, like 100. So any query you can put just to check that what are the movies available, like greater than equal to 100. So here, like the longest movie is coming like this, the Black Mirror. This is the title. No, again, no director. These are the cast, United States, and was released in 2018. Okay. Now, as I told, like if you want to see all the movie, which is, like more than 150 minutes or 100 minutes. So the query is very simple. You can just insert another cell over here. Just changing the name of the data set. And I will just put some value here greater than equal to 100. Okay, so it is giving me all the movies basically, which is more than 100 minutes, okay, duration. So this is the way you can analyze the data. And even if you put 200, so it will give all the movies, which is more than 200 minutes duration. So see 229, 273, 204, so like that it is coming. Okay, so this is also some kind of analysis you are getting from here, okay. Now the same thing I have done for the shows. Now, what is the show's duration? It wasn't coming in season. So I have just tried to eliminate season word from the show. So I can get it in 1, 2, the discrete values, right? So now it is coming as, if you see, it is coming like this. Still, if you see here, one data has come as 2S. Maybe they have, represented season as S. So that is how they have represented. So it is coming, the 2 and S is coming. So again, I have replaced, like if you see this data, you can understand that what you need to do basically. And you replace that 2S with the S you are replacing with the blank data, right? So now the data is clean. Basically, it is a full numerical data, 2, 1, like that, the discrete values. Okay. Now, again, like, see in the data description, it won't come because it is an object variable. So if I show you here, sorry. So only release year is coming. Still now it is an object variable. So it is not a proper, like pure numerical value. So we need to change it again to a numerical variable. So I have again taken the same code, just, like replace the variable name over here. And now if you see, now the duration is fine. now the duration is coming in the statistical measures. The statistical measures are coming for the duration. Now, if you see here, the minimum is 1 and the maximum is 17. I am not going into mean and standard deviation because this is not essential for this data set now. And this, again, it is a discrete data basically. So it will always, it won't be having, like the decimal values and all. So maybe we can take out a mode of it. So let's see what is the mean and the median, the max value. So minimum is 1 season, that is okay. Like many series will be there which is of 1 season. But what is exciting is some episodes or some TV shows are there which is having 17 seasons. So that is, I think, our longest episode kind of. And the curiosity arises over here that which other episodes or TV shows are there which is having 17 seasons. Okay, so that we can check here. So here also I have found out like some of the value counts based on this duration only, which is occurring like from the last, like 17. If you see, the 17 is only one TV show is there. Then 12, with the 12 seasons, there are 2 TV shows. Like with the 15 season, there are 2 TV shows, and till now, till 6 I have seen, like the last 10 data I have seen, basically the 10 rows. So for 6 there are 33 shows. So I am basically interested on the 17th one. But still, if you want, you can just check, like more than or equal to 30. So otherwise you can just put equal to 17. That also it is okay. So this is giving me all the names of the shows basically. So if you see here, the one which is with the 17 seasons, basically that name is Grey's Anatomy. Then with the 13 seasons, Heartland. Then with the 15 seasons, Supernatural. Likewise, you can check all the data. Okay. So likewise, like you can analyze this data set. So I have tried to analyze this data set accordingly, because not that everything you can do on every data set, because there is no scope of like treating the outliers or anything over here, because we have very less numerical data in this data set. Then I have seen the longest shows rating also. And if you see which is this rating, that is TV14, which is occurring for 4 times in the longest shows. So in this data only, like which is more than 13, the duration is, 13 season, the duration is, what rating it is there, like with which rating it falls, the category, the TV14, that is not suitable for under 14 years children. Okay, and the one is TVMA also. Okay, so these are the ratings. Then I have tried to plot the heat map based on the how the contents are added, or which is a maximum month or highest month where the contents, like Netflix adds the content. So, or at the do the releases. So this is a month-wise heat map you can see over here, and it is showing that the highest value is on November 2019. And from the color itself, you can understand. If I show you this data, probably you won't be understanding so well. But since I have plotted a heat map, from the color variation only, you can understand like which is having the highest values, basically, like the month which is getting the most, releases or the most addition of the content. So November 2019, again July 2021. So this is I think the latest which was there. And one was January 2020. So this is how you can, do some analysis on the data set. Since this is a very simple data set, so this is the way you can do some analysis. And also, I shown you how you can do the univariate. So univariate is basically only when you are doing on the one single data point, you are doing some analysis, that is univariate. Bivariate means when you are seeing that what is the relation between basically the 2 variables, the data points, then you are doing the bivariate. Multivariate, mostly for multivariate, we plot the heat map, we see the box plot, violin plot like that to see, how the data is correlated. So likewise, you can do, the analysis of this data set. Now, your analysis on this data set can be a little bit different depending on maybe the more things you want to, the more insight you want to get from this data set. But this is a thing you can do. I have given an overview. Hope this helps you and it gives you some kind of insight. I will stop my session here. Can I take the Q&A?
Yes, guys. Before we proceed to answer your question, I'd like to request all the attendees to please fill in the form like fill in the poll about feedback, as it helps us to conduct more such sessions.
Okay, so shall I go for Q&A now?
Yes, ma'am, please.
Okay, what is the source of your dataset? It is from the Kaggle. You will get kaggle.com. So there are many datasets. You can just search for any dataset you want to do. You can do the EDA on those datasets. Even the code is also available for some dataset. You can check, and it is a good source. So I always download the data from there. If you want to see some public dataset, that also you can see, like from if any public API is available where you can fetch the dataset, that you can do. Or you can do some web scraping techniques from some website if you want some specific data. So that also you can do. I have a dataset of house app pricing that have 2 columns, bathroom number and room number. The number of rooms with missing values on these columns is considerable amount, 60%. What approach can be used to estimate the values of the missing values? I was thinking about ML, maybe the classification. Is there a better, faster approach? Yes, ML, like algorithmic imputation you can do. Otherwise, you can check any other dataset if present, then you can relate to that dataset and get these values. It is not always, like applicable, like to get the, because this is kind of a, like the, it is not applicable that you will always replace with the mode, because the number of washroom which is occurring, or the number of room which is occurring maybe 4 maximum times or 3 maximum times, it is not like suggestible you can impute with always with the 3 only. So you can check with the other dataset if it is available, some kind of reference or some other kind of columns which can be like applicable, like you can do some interpolation of the data. So it is basically depending on your data set. So if you can interpolate with some other column and check some correlation, that way also you can impute. Otherwise you can do ML approach also, so that is also fine. Age is not discrete. No, age you can take it as a continuous, because you can take it as a district. See, it depends basically. So we can write like 10.5 years, right? So it is not, it is containing some decimal value. And sometimes we are rounding and keeping it as 11 years or 10 years. So that is also okay. So it depends. When doing EDA, did you often use Python or sometimes use Excel? I use actually 4 tools for doing EDA. So sometimes I use Python, sometimes I use MATLAB, sometimes I use R also, and also Power BI. So you can do EDA in Power BI also. It is a great tool to do the transformation, like the handle missing values and all. So all the 4 tools you can use. So there is no technology constraint. Whatever you like, you can use. Again, I am not stuck to the one technology, and I don't learn syntax also. Basically, I go to Google and search for the syntax. I am very honest about it, and I don't want to remember it. I just want to understand the process and what I need to do over here, like the strategic decision I need to take over here. This is, I think, the analytics Vidya will share with you. Where I can find this notebook, I will share this link. This is already present in my GitHub channel. Yes, the dataset shows unknown as text. So that is what we have done over here, because we don't have any target variable over here, or neither like any rating was there or any gross is there, like the profit on the movies or anything. So it is like we have replaced with unknown. It is a safe thing, because it is not like suggested that you can replace always with mode. Not suggested at all. How can we separate minute from 90 and convert rating from 1 to 5? So how you can separate minute from 90, that I have shown in the code. It is a very, very simple code. You can use lambda expression also. And convert the rating 1 to 5. So this you can actually do the binning. So like if you have the data and you want to, based on some parameter, you want to just group the data like 1 to 5, then 5 to 10, that you have to use the binning technologies or binning processes. And that is very simple. The syntax is very simple in pandas. So it is kind of a derived matrix. You are deriving some column from already existing column and you are binning on it, as I explained on the data. Can you please explain Lambda function, what it does, what to use? So it is basically, like replacing the for loop. So instead of writing an entire for loop and doing the things, I used to use the Lambda function. So it replaces, like in one line code for the for loop, you can say. So it is just replacing the for loop and doing the operation for all the values in that data, in the data set. Okay, you will definitely get. Don't lose hope. Like at some point of time, we all face this. So don't lose your hope. Can you give an example? So interpolation, as I said, you write like one example I have given, like for the, if you are analyzing some loan data set, and if you are seeing that there are column present as price of the good and the loan you have got received, then you can like check some correlation, because generally what happens is, what is the price of the good, that amount only we apply the loan generally. Like it is more or less similar only. Sometimes we do the down payment and take less loan. Sometimes we take, like, show the price more and take more loan. That also happens. But the relation is that it has a very positive correlation. The data is more or less same. So interpolation can be a good example on that, that when you are, like interpolating your loan value, basically, if your amount of good is missing, but that you need to check basically that whether there is any good positive correlation, whether the data pattern is always like more or less equal only, then I think this will applicable. Extrapolation is like when you are extending some pattern. So already a pattern is flowing in your data set and you're extending it. Suppose you are seeing that for gender says, or says for country. So US 3 times it came, and then India it came 2 times, and then Japan came 3 times. So if you have a same number of data set in the missing values, you are trying to, like extrapolate the same pattern into it. Like US you are putting 3 times, again you are putting India 2 times, and Japan 3 times, likewise you are putting. So but it can be risky, like it may not be the case all the time. So it is not, like suggested to do extrapolation until and unless you are very sure, or you know the data and you have that experience on the data. Can you share some idea for creating some unique model for my portfolio? Yes, you ping me in my LinkedIn, I will share the idea with you. Can you get the movie scene statistics with related to the other factors, festival, where? Yes, but these factors are not given basically, and the movie scene statistics is also not given. So if these variables are given, you can do a multivariate analysis on this. So basically you can take all these variables which can, like give the or relate to your movie scene count. Then you can, like do that. From that analysis, you can understand how to handle the missing values in Netflix dataset. That I have explained some of the like missing values which I have handled. But it is not, like the only way to handle missing values. Sometimes the numerical values we impute with median because the data is not symmetric. So if it is not symmetric, then we impute with the median sometimes. So that is also one way of handling missing values. Yes, I will share the code. How do we remember? I don't remember the codes. I don't recommend to remember the codes. Don't even go and like behind the syntaxes. Then you will actually not understand the process. Please share GitHub profile link. That I will share. Okay, thanks for this. We can use the Spark along with pandas. Yes, Spark is used for the very big data. You can use, but it is not, like for so too much used in the EDA. So it is mostly, like for machine learning and all. But the problem statement for this EDA. So it is basically, like EDA is mostly on the data analysis thing. So you are analyzing the data set fully. So EDA is something which where you are showing that, seeing the anomalies, you are doing some visualization, that analysis you are doing. So there is no problem statement as such. Yes, I will share the Jupyter notebook. Can you please share the interview questions and data science? Interview questions, I think you can get ample in Google and YouTube also. I don't have anything handy right now, but I can find out and share later. while doing it. Okay. So these are the questions today. Let me show you the last line of code somebody has asked. So this is the last line of code basically. So where you are, like plotting the heat map. I have actually, like segregated the year and month from the date added using the lambda expression, and then I have, like ordered the months, values, and plot the heat map. So again, this code is available in the net. So you can find the data visualization code for heat map. You can go to the pandas data frame code. The code you have to just, like understand and work on it accordingly. Don't go behind the syntax, I will suggest. Because if you're going behind the syntax, you are stuck in one technology. And I don't recommend that. Like, don't get stuck in one technology. Okay, so these are the things, and someone has asked for the lambda expression. So this is a lambda expression. So if you see here, like instead of using a full for loop and iterating all the values in this column, I have just used a lambda expression. I am just, like converting the object to the integer, and that is done. Like in one line of code, it is done. Even for the other one, you can see that instead of using the for loop, iterating in the for loop, I'm just using the lambda expression. So if minimum is in the x, replace x with the blank, like this value with the blank, else you will return the x. So that is the meaning of this syntax. Again, I will tell you, don't go behind the syntax, because I am not remembering the syntax. Anything I am not remembering. It is your practice, and you can find it in Google. That is how you can do it. Okay, I think it gives you some insight, guys. So don't lose hope. It is like very interesting. Just, like keep coding and keep understanding.
So yeah, thanks a lot, Munmun. On behalf of the analytics there, I'd like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. With this, I'd like to we'll be back with another session of data around 4 Jan. The link is in the chat section. Till then, bye bye and keep learning. I hope our session is over.